Welcome to This Explainer. Today, we're going to explore how to truly modernize threat hunting by throwing two absolute titans of the security world, Microsoft Sentinel and Splunk, into the ring for a head-to-head architectural comparison. If you're fascinated by how generative AI is completely reshaping the Security Operations Center, well, you are in the exact right place. We're going back to basics with the architecture to see exactly how these two powerhouse platforms handle automated, real-time threat hunting. Okay. Let's just jump right into the trenches here. Picture a scenario that honestly strikes fear into the heart of any SOC analyst. Your SIM just lit up with suspicious PowerShell activity. The clock is officially ticking. The massive question for modern security teams right now is this: can a generative AI wingman actually synthesize that whole attack story before you've even had a chance to open your dashboard? Can it explain the attack, generate the right hunting query, enrich the evidence, and trigger containment before a human manually connects those dots? Let's find out. So, here's our battle plan for today's explainer. We'll start with the threat hunting hook, then dive into Microsoft Sentinel Operations and Splunk Enterprise Security side by side. After that, we'll weigh up the platform fit and finally lock down those essential GenAI guardrails and human governance. Starting off with Section 1, the threat hunting hook, and that literal 90-second race from the initial alert straight through to containment. To really see this play out, we're going to track one specific attack story, suspicious PowerShell activity, across both platforms. And honestly, this entire explainer boils down to this one crucial mantra. AI proposes, SIM verifies, SOAR acts, and humans govern. It's kind of like the AI is your Jedi instinct, spotting the patterns and summarizing the chaos. But those deterministic SIM and SOAR controls, they are the ones actually validating the evidence and executing the mission, and always under your strict command. Never forget that hierarchy. Moving into Section 2, Microsoft Sentinel Operations, where KQL meets Security Copilot. In the Sentinel universe, you're seamlessly pulling in telemetry from everywhere: identity, endpoints, the cloud, and you're querying it all with KQL, while Security Copilot steps in for the heavy analytical lifting. What's super interesting about the logic here is that we're running a tightly scoped 15-minute hunt for that weird PowerShell behavior. Using that explicit 15-minute window is brilliant because it keeps compute costs down and filters out unrelated noise. Plus, it's checking for encoded command patterns without blindly assuming every single match is malicious. It just proves that even when the AI layer translates your intent, Sentinel and its KQL engine remain the undisputed deterministic system of evidence. Once you've got that evidence, the automation flow instantly takes over. An incident is created, an automation rule immediately evaluates the metadata, and then a playbook fires off to enrich the indicators, pulling in IPs, hashes, users, all that good stuff. But here is the absolutely critical part. It hits a hard stop. There is a definitive approval gate before it ever isolates an account or device. The AI and the automation did all the prep work, sure, but a human must open that gate. All right, shifting gears to Section 3, Splunk Enterprise Security. It's all about SPL and Splunk SOAR. If Sentinel is all about KQL, Splunk is obviously living and breathing SPL, deep correlation logic, and its own AI toolkit. Let's run that exact same PowerShell scenario through Splunk. It uses that identical 15-minute look-back horizon, just written differently, and hunts down those same encoded commands. Then it aggregates the execution counts by host, user, and parent process. It is genuinely fascinating to see how Splunk reaches the exact same destination and proves the exact same hypothesis, but takes a totally distinct architectural route to get there. And the automation path here? It's just as rigorous. Splunk SOAR orchestrates the playbooks across all your connected external tools. It extracts artifacts, triggers enrichment, normalizes the evidence, and builds out the case file. And again, notice the end of the line. It leads right straight to a critical policy decision and a human approval gate for containment. Two completely different platforms, but their philosophies on safe, governed execution mirror each other perfectly. Which brings us to Section 4, Platform Comparison and Fit. Time to choose your SOC's weapon. So you've seen both engines running. The question isn't which has the flashiest AI. It's which one actually fits your existing base of operations. Sentinel is just a no-brainer if you're living in a Microsoft-heavy universe, meaning deep roots in Entra ID, Defender XDR, and broad Azure investments. But if you're dealing with a massive web of third-party data, crazy complex orchestration needs across different vendors, and you already have a big Splunk footprint, Splunk is an absolute beast for heterogeneous telemetry. Breaking it down technically, under the hood, Sentinel is definitively KQL-centric, leaning on logic apps and Security Copilot.
Splunk is SPL-centric, relying on its dedicated SOAR playbooks and the Splunk AI toolkit. They are two entirely different vehicles, but both are fully capable of driving you to a highly automated SOC. Section 5. Implementing Gen AI guardrails. Let's talk about the production-grade Gen AI workflow. Because here's the reality. Whether you go with Microsoft or Splunk, dumping unrestricted raw logs directly into a large language model is basically a recipe for disaster. You have to build a shielded production-grade loop. It starts with a risk finding from your telemetry. Then, and this is key, you do not send everything. You use bounded context retrieval to grab only what's necessary, like recent events or asset criticality. That bounded package goes to the enterprise LLM. Then, a structured output validator rigorously checks the AI's response against a strict schema. Only if it passes does it hit the SOAR decision layer, where KQL or SPL actually runs and human approval is requested. Think about the data the AI sends back. We don't want a chatty, conversational paragraph, right? We force it to provide machine-readable, structured data, like a hard numerical confidence score, exact MITRE techniques, and specific entity extractions. And most importantly, a simple Boolean value demanding human approval. By locking down the output structure like this, you literally prevent the model from going off the rails with unstructured hallucinations. The SOAR platform can programmatically read that structured data and know exactly what to do next without guessing. Finally, Section 6, Governance. Humans in control because we never trust blindly. As we wrap this up, we have to talk about separated authority, because it's the only thing stopping an automated system from triggering a massive, self-inflicted business outage. Here is the absolute, immutable law of modern SecOps. You must never allow model confidence alone to authorize a destructive or business-disruptive response. I don't care if the AI is 99.9% sure a critical server is compromised. It cannot isolate that server on its own. The AI is just the co-pilot preparing the containment action. You are the commander giving the final order. To actually enforce that, your checklist has to be ironclad. Automatically reject any AI output that fails your schema. Treat the AI's confidence score purely as a way to rank your queue, not as some absolute mathematical proof of an attack. Verify every single extracted entity against your original source events, and require hard evidence references for any action the AI recommends. Grounding isn't just nice to have, it is absolutely non-negotiable. Bringing it all together, the ultimate winner in the SecOps wars isn't just the platform with the most AI bolted onto it. It's the one that lets you harness that AI reasoning and seamlessly convert it into a measurable, observable, and tightly controlled workflow. Whether you're running KQL or SPL, the end goal is exactly the same. So, I'll leave you with this provocative thought to chew on. Is your SOC using generative AI today just for a little basic investigation help, or are you actually ready to build a fully automated, governed response pipeline? Thanks for diving into this explainer with me.